model-based definition, or MBD, is the practice of embedding all necessary product and manufacturing information, PMI, into the 3D model directly. Includes things like annotations, dimensions, tolerances, GD&T, surface finish information. So typically what you might try and show on a 2D drawing, but you're showing that in the 3D environment. It allows us to hopefully better refine and decide upon, I guess, a single source of the truth. Because at the moment, if we have a 3D model and we have a drawing, we have two separate things, and which one is actually the right one? Okay, so it just allows a lot of problems to be solved, and we'll see this as we go through. Okay, so it doesn't necessarily replace it, even though the slide says that it can. I mean, at the moment, it hasn't replaced it fully overall in the manufacturing environment. However, it can, and we have some customers who already are down this path, and we'll see another slide at the end of some global type organizations who have actually gone down this path. Okay, so there is benefits, of course. So the PMI lives in the model. Okay, dimensions, tolerances, notes. Again, this is just reiterating what I said before, but provides a single source of the truth and continuity across the life cycle. So we don't have two separate documents to manage. We have one. And also downstream automation is important because we don't have to convert a 2D drawing back to 3D in order to manufacture it, or to in order to place it on a you know, some sort of manufacturing type machine, 3D printer or otherwise, you know, either subtractive or additive manufacturing type operations. We can directly use the model. So this is just, if you're not sure what we mean by PMI, product and manufacturing information. Okay, so as it says there, I mean, if you're familiar with CAD and drawings and so forth, you probably understand all of this or intuitively, but it is information that's traditionally shown in 2D drawings, but can be embedded inside the 3D model. Example off to the right, very simply, showing some GD&T information. Okay. It's accessible to all stakeholders, and I guess what that means is that if we're using an environment where we might need to export a document, we can export it in 3D format, step perhaps, or PDF, 3D PDF, or if we're in the PTC ecosystem with inside Windchill, inside Creo View, we can, you know, everybody can view this information directly on the 3D model. And the benefit of, I guess, you know, jumping ahead a little bit, is that we have a 3D model, so that we can, if we have the 3D model, we can measure it. Okay, whereas if we've got a 2D drawing, sometimes it's a little bit arbitrary as to what that particular annotation might mean, because we only can see that model from a 2D perspective, and hence that then reduces the risk of you know, miscommunication that occurs there. Okay, so 2D drawings are time-consuming and error-prone. That's a matter of opinion, I suppose. However, you know, like if you've ever had to do it, to spend the time creating a 3D model and then realize at the end you then have to document that in 2D, it seems like there's potentially additional work there. If you could just send somebody the 3D model, maybe you'd be happy for that. So there's that sort of redundancy. And the out of sync documentation, like if we take the 3D model, we generate a 2D drawing, we might generate a DXF, or we might generate a PDF. There's no link back to the original model there. and it's not the 3D model. So if there's any questions or any things that we can't understand or we can't visualize that, then downstream we're probably going to get feedback and questions coming back about that. Okay, so the whole idea is to centralize and to have, again, go back a single source of the truth. So here's an example of a drawing, which you can see on the left, which was communicated, let's say initially, via 2D. So if you understand all of this stuff, then you might read that and say, okay, this could be interpreted in multiple ways. Now, if we look at the real world, these are photos of the real world result. What we're focusing on here is this hole. So this hole here. Now, with a drawing-based definition, this was actually created with a through hole. However, with a model-based definition, it was not a through hole. It's not what it was meant to be. If we could, obviously from this drawing and this sort of section of the 2D drawing that we can see here, it's potentially arbitrary what we can see, but imagine if we could see that in 3D, and if we were at the stage where we're manufacturing this thing and we had a 3D viewable, and we could then look and see, is that hole through? I'm not sure what these annotations mean, but let's go have a look at the 3D model and measure it and so on. I'm sure you can imagine that we, like we have more visibility there.